Welcome to Samba Samba. Enjoy the video.
You start by confirming basics, why logs compress ranges and make multiplication additive. First, set your calculator to base 10 logarithm and practice with scientific notation like 1, 0 E3. Then convert concentration to the appropriate ionic form. For acids, find H+. Once done, compute pH as negative log of H+. Make sure to keep track of units and significant figures because the log changes precision. These immediate steps put you into problem-solving mode fast. You now apply logs to intermediate problems, buffer calculations, weak acid dissociation, and equilibrium constants. For buffers, compute pKa from Ka, then use Henderson-Hasselbalch to find pH from ratio of base to acid. For equilibria, take negative log of Ka to get pKa because it simplifies comparisons. Conversely, 10 pKa returns Ka. Once done, use change of base formula only if necessary, and always propagate uncertainties. Because log transforms affect significant figures, you finish by converting back. When you get pH or pKa, use 10 to the negative of that value to recover concentrations or Ka. Then verify plausibility. For typical aqueous systems, pH should be between 0 and 14. If you see values outside that range, reassess concentrations, units, or ionic strength. Make sure to round correctly because log operations shift digits. If something goes wrong, check calculator mode. Re-enter numbers in scientific notation, and replay the steps slowly to spot the error.
Thanks for watching. Consider subscribing if we helped you.